Okay, so 5.4 is about completing the square. And completing the square is another technique that we use to solve quadratic equations. So the main thing here, the goal is to create a perfect square trinomial. And I'll explain that as we go. And factor it. So in order to complete the square, you must do a few steps. And we've got an equation here that we're going to use as an example as we go through this, okay? So is it factorable? That's the first thing you want to ask yourself. And remember that factors look like this, where you'd have x plus or minus some number and x plus or minus some number. And in this case, picked one that is not factorable. So, but if the answer was yes, it's factorable, then you should factor it. But if it's no, then you keep going. We're going to complete the square. So first of all, you have to organize this polynomial. All the variables need to be on the left and the constant on the right. So that's the rule for that. Variables to the left and constants to the right. So in this equation, you got this x squared plus 12x. Those are your two variable terms. And then that 37 is a constant, just a number. So you're going to move that 37 over to this side by subtracting it from both sides, okay? So when you take this, x squared plus 12x plus 37 equals 0, what I'm trying to move is that 37 to this side. So if I say minus 37 right there and minus 37, then I wind up with x squared plus 12x equals negative 37. And we need it in that form to actually start the process of finding the square. Okay, so in step 3, we need to square the term and add it to both sides. And when we say that, we're talking about the b term. Not this one. This is the b right here that's just attached to that single x. So we've got this 12 in here. And we got a formula right here. We're going to use the formula, the b number, which I just talked about being that 12 attached to that single x. And then we divide that by 2. Then we square the whole thing. So in this case, we'd have 12 divided by 2 squared, which is 6 squared, which is 36. Then we're going to take this 36 and add it to both sides of that equation. So it's going to look like this. X squared plus 12x plus 36 equals negative 37 plus 36. And when we simplify that down, we wind up with x squared plus 12x plus 36. We're not going to move this yet. Equals whatever that simplifies to, negative 37 plus 36 would be negative 1. So I had that lesson over complex imaginary numbers, where we'd be trying to take the square root of negative 1, and that's fixing to come into play when we talked about factoring the left side and solve. All right? So we're going to factor this into two binomials, and that is the left side, the big side. But we get two binomials here, x and x. Now, if you don't know how to do this, there are calculators that'll help you do this factoring, okay? But it's the product of what that gives me 36 and adds together to give me positive 12. That's the product there of what times what gives me 36 and also adds together to give me 12. I'm going to skip over here and show you real quick. I want to look at 36's factors. Three times 12, 4 and 9, 6 times 6. 36 is a perfect square, and that's what we did. We created a perfect square number right here, okay? So when we do that, then I'll look at this sign. If this is positive and this is positive, then both of these are positive. What is the perfect square for 36? 6 and 6, right? So now, that's my factors for the left-hand side. And I still have this equals -1. So when it says factor the left-hand side and solve, by solve, it means to take the square root of both sides. Take the square root. Well, if I take the square root of x plus 6 times x plus 6 equals the square root of -1. These are the same, right? They're being multiplied together. So that is the root right there, x plus 6. So when you're taking the square root of the left-hand side, you get x plus 6 equals the square root of -1. Now I want to solve that. Last step. Solve for x. At this point, I'm going to solve for x. So I've got x plus 6 equals something. I'm going to move that 6 to the other side and find out that x equals -6 plus or minus the square root of -1. Sorry, I'm going to move my paper. And we did this in a different lesson. That square root of -1 is represented with I, the imaginary number. So when I'm done replacing that right there, that's the answer. Those are the complex factors of that equation that we started with, x squared plus 12x plus 36, or plus 37. That was the original quadratic. So I'm going to do another one, factor one more for you, and then I'm going to give you a couple that you can work on, and I'll check them if you need me to, or you can reach out to me for questions in email. So when you're talking about completing the square, there's kind of a little form that everybody goes through here. You write x squared minus 11x, move that -15 to the other side by making it positive. Leave this space right here. Because now I'm going to come back and I'm going to take this -11 right here. And this is, don't let this get crazy on you, okay? But you're going to take that -11, divide it by 2, and then square it. But in this case, -11 doesn't divide evenly by 2. So this is how you handle an odd number that won't divide by 2, okay? So you say -11 divided by 2, and I'm going to square that. When I square this, I say -11 times -11 is 121. And 2 times itself again as 2 is 4. Then I'm going to take this number and add it back in up here. Okay? Now, at this point, since I've got that as a fraction, I need this guy as a fraction to work with him. This gets complicated, okay? So I'm not trying to overcomplicate it for you, but you need this as a fraction. So instead of 15 as a whole number, I'm going to change that into a fraction over 4. So it's 15 over 1. I'm going to convert it to something over 4. 4 times 15 is 60. So I just replaced this 15 with a fraction that has the same denominator as that one. Now, when I add this to both sides, I added it here to the left, I still have to add it over here, 121 over 4, to that right-hand side. That's what I did back up here. I added 36 to both sides, and I have to do that here even though it's a fraction. So now, I'm ready to move down here to this next level. And the thing about this is you would automatically be able to factor that. What did I do right here? You know, what was right here that I added both back to both sides? What was this that I squared to add back to both sides is what I'm trying to say. And I squared this negative 11 over 2. So it's x squared, x, since this is positive and that's negative, right? I have to have both of them negative. So it's x minus 11 over 2. That's the two factors on that side. That has to equal, if you put 60 and 121 together, you'd get 181 over 4. As I go from here to solve for x, now, first of all, this can be dropped because that's the factors right there, but I'm taking the square root of everything. That's going to get rid of this, and I've got, keep writing down here, I got x minus 11 over 2 equals square root of 181 over 4. Almost be too much. So I want to solve for x here. I'm going to add that 11 over 2 to both sides. And x equals 11 over 2. This is going to factor. And you don't have to worry about trying to factor that 181 because it's not a perfect square. So it is 11 over 4 plus or minus the square root of 1 over what's the square root of 4? 2. That's a lot. A lot. So you should look at that Desmos calculator. It's going to let you put those problems in and factor them. Or maybe MathWay calculator will let you do the same thing. If you know how to use that TI-84, you can do this on TI-84. All right, a couple of problems you can try on your own. Here's one, x squared plus 10x plus 21 equals 0. And x squared minus 5x equals 12. That's just a couple of example problems. You can try those on your own or find a calculator that works for them. I'll give the solutions to those two problems at the first of video B. So this is going to be the end of video A.